So, introduction to monads. When you start to look at functional programming in general, or start to play with Clojure, F#, or maybe with Scala, you run sooner or later into monads. So hopefully later than sooner. So what you do, usually it sounds so strange. You Google for it, you find maybe the Haskell documentation, or read few of the Hounded's introduction to monads blog posts on the internet, from which actually everyone describes this from a different perspective because approaches on a different aspect of monads. And you ask yourself, yeah, what the heck is it? So why do I actually need it? So since many people are new in the group, new to Clojure and to functional programming, so I hope it's actually of interest. I will focus in this talk, but I will focus in this talk only on the implementation aspect of monads, not on the theory, which is actually a totally different universe. So just what monads are, how to implement monads, and go over a few use cases. So monads were introduced into Haskell. Haskell is a lazy and pure functional programming language. It's actually extremely lazy. When you write something like first equal getLine, you assign the function getLine to first. You don't execute it. So getLine actually reads one line from the standard input. So when is getLine executed? The getLine is executed when the value of first is needed. So in this context, this would be here for the print statement. So first you would call getLine to get the last name, and then getLine to get the first name. So what is definitely not expected here. What about the print statement? So the print statement, print does not return any value. So no one depends on the value of print. What should print actually be executed at all? So there's no reason for it. So monads actually introduced a notion of kind of actions. Actions as of functions that are executed in sequence one by one. Haskell is pure as well. So when you have a function, and you call this function with the same arguments, you always get the same result. So now, when inside the function you call getLine, or read, for example, a file, or maybe even generate a random number, the result of the function is going to be different. So you have a side effect. So monads not only introduce the notion of the actions, but at the same time you are able to manage a context where I/O monads or I/O actions like write to file, read from file are actually executed, and the environment or the context is called even the world. So every time you execute an I/O action, you change the state of the world, and this makes reasoning about your programs first possible. So Clojure is not lazy, so Clojure is not pure as well. So why should we actually care about monads in Clojure? So where is the motivation? Let's take a look at a small example. Let's assume we are writing a test framework for services, like a HTTP server, maybe an FTP server. So for this test framework, so actually what I do at work. So for this framework, we like to provide a DSL a test engineer can use to script test cases. The DSL could look like the following one. So run test is like a JUnit test function. First, we open a TCP connection to a server. Then over the connection we just open, we send a request, for example, a message like a HTTP request. On the response we get, we try to assert that we got 200. Okay, when everything is fine, we send a login message and so on. Okay, so how can we implement it in Clojure? The first approach is we expose in the DSL the entire language, so Clojure itself, and we wrap it into a let statement. So the TCP function returns a connection. The connection I pass as an additional argument into my send function, which returns a response. They are passed into the assert, and so on. This is a relatively simple snippet, so you see what's going on. But when we add into it error handling, let's say connection timeout, or maybe an invalid response, it gets pretty quick, really complicated. So when I throw this here at a test engineer who just tries to run single message and I said 200, okay, believe me, I get thrown at me really quickly. So another approach is we introduce kind of test session inside the test function that I run, test session or maybe a state. So I could implement it this way, like a special variable. So first what I do, I bind my special variable into a thread local. My TCP function creates a connection and puts it into my test session, into the map. Let's say it is a map. So the next function I execute is the send function, goes into my map, takes the connection, executes the send, and writes a response into the map, and so on. So actually, I could implement this here using just the test session. But in this context, or when I do it this way, I have to consider the following. Will I actually run different tests in parallel? Okay. So do I really like to implement it as a variable and bind it to a thread local? Or maybe I will use an underlying connection framework that actually executes the sends, gets a response, and the parsing of the message, for the parsing I will use another thread, or even several threads to do the parsing because the protocol is maybe really complicated. So when I decide to go with a var, rewrite it into use a reference, I have to change the entire implementation. But actually, at this point, why should I care about it if I execute it in one thread, in several threads, and so on? The only thing I really know that I'm interested in is one, that my actions are executed in sequence. So what I really need is some kind of state that is created only for the running function, that is visible only to the actions that I have in this function. That's all. Okay? So it's relatively simple. So let's implement it. So let's go back. So what do we do here actually is we are dealing with actions. So actions are of functions that we execute in sequence one by one. Okay? So the first thing what we need to do is we need to have a way or a function that allow us to convert any data object, like a map, like an integer, into an action. So it is a function. For this we can define the function return, where we pass a value. Is it big enough, or should I make it bigger?
Bigger would be good.
Yeah? Like this? Okay. So define the function return. So when I execute the function, the result is another function with no arguments that returns the value when I execute it. Just to establish the notation. So when I write 5, I'm actually creating an action. Okay? So when I execute it, the result is a function, so my actions that I have. Okay? So when I execute it, I get the result of the function, which is 5. Okay? So now we can see the action as a wrapper around our data. Okay? So what we like to do, we like actually perform some operation on the data object inside the action. So for this we need another function. The most flexible function to do it is the following one. We call it bind. Okay, this takes the action I like to operate on, another function that has the operation. So what we first do, we execute the function to get the result back. And on the result, I pass to my function that performs operation on the data inside. Okay? So here's one requirement. The function that I pass to my bind not just returns the result of the operation, but it has to return an action. Okay? As an example, when we have here return 5, let's implement an increment function for it. So def inc, it takes an action. Okay. First what I do, no, it takes a value. So first what do I do on the value? I increment my value. Okay. And the function needs to return an action, so I just return it. Okay. So now I can use it, for example, here. Okay, when I execute it, you see it's another action that I got, because f_inc returns a function which is returned by the bind. So I can throw it into another bind. Okay, and of course I can execute it. But it returns 7. Okay. Okay, this is not really interesting. Or let's make this here more visible. So let's rewrite it as following. First, I combine the bind and the function to another function. Def inc. Now I pass an action. So I execute the action. So and pass the value to my function, which returns inc of my value. Okay. So I can rewrite it to here. So this should return 7. Yes. Okay, and this we can replace with a standard Clojure threading macro. Thread, how do you call it?
The thread first macro?
Thread first macro. Okay, so I create my initial action. 5, then so the result should be the same. Yes, it is the same. Okay, and we don't need f_inc as well. Okay, so far any questions? Okay, this is not really interesting, just an increment function. Let's add one additional, like here, add. So to our action, we like to add an additional number, like for example, if 5 or 6 or an additional integer. So we perform the same operation. We first execute our function, so our action, and to the value we add whatever we pass to the function. So like this. Okay. So what did we gain by doing this here right now? So actually, we didn't gain anything, because I can do exactly the same thing in plain Clojure. And I get the same result. Okay, so this is the most complicated int and add functions you probably saw, without any advantage. Okay, but what about something like divide by 2? Fine, but divide by 0. So here I run into an exception. Okay, so let's say that this value comes from another calculation. So this is another variable or something else. So when I treat the result of my v as an error, I need to check with the if statement above, is it a null or is it not a null? Or maybe I put a statement around it, exception around it, try catch around it to actually catch it and return an error. So I have different ways to implement it into the code. But in general, it would be nice when I have different actions in my code that perform an operation, that actually I don't have to do it for every action. When I actually get it for free, the error checking in my execution. And since we have the abstraction of the actions on top of our base functions, return and bind, we can put it into the computation. Okay? As an example, let's remove it of what I mean. Okay, let's implement the divide function. So now, Okay, so the first thing what I need to do, I need to check if it is 0 or not. My value. At this point, I have to return a nil. So I'll return a nil. The computation failed or is invalid. Okay, so I'm returning an action with the value nil inside. So when my action, when it is not a 0, I actually perform the computation, divide Vn. So at this point I can do def2. Okay. Okay, I forgot something. Yes. Okay, here's my result. Okay, one more thing we have to do is when I execute my bind, okay, inside these actions, I need to check when one function returns nil, I cannot execute the next one. I actually have to stop here and execute it. So I can put into my bind function where I can first execute my action, check if my value failed. When my value failed, when I get a nil, I return a nil. Otherwise, I go forward and execute it. Okay, so this is my computation. When I replace it with 0, the result of my action is nil. So the computation failed. I don't have to implement it here in the layer where I actually work with my function. It is provided automatically by my functions bind and return, and I build my actions on top of.
It
Okay.
will bubble through all those, right?
Exactly.
Every bind will check that bubbling of the nil.
Exactly. This is correct. Actually, when I execute,
Short circuit is what I'm asking.
it is short circuit. Yes,
Short
it is. It does not bubble up. I immediately return it. So this function at this point returns the nil. It passed to my inc function through the bind. At this point, I return the last value of my function out. I don't go back anymore.
Oh, you don't call f up instead.
Exactly. I don't call anymore. At this point, I don't call this here. The next function in the chain, I just return. Exactly. Okay? So when I have multiple functional actions in my computations in a chain, I don't have to check for it anymore. Is that an advantage? Okay? Questions so far? Okay. So let's go back to the original problem. What we like to have in our action is a kind of state that is inside our computation. Yes.
You don't know where this failed, or how you just know that it didn't succeed. That's the trade-off.
Okay. No. You know it. When I perform here the division, okay, on my action, I return here a nil. Okay. So this division, the result of the division is. So this function is executed here, whereas the result of it is a nil. I check for it and just return my nil. Does that answer the question? Oh.
Well, no, I was just saying, if you have multiple things that could fail and return nil, you don't know which one actually failed. That's just a...
Exactly. So you don't have it, but you could provide additional context into it, where you actually write exactly the error message or where it failed and so on. You can do it. So this is going to be the next step.
Okay, thanks.
Okay, so going back to our original problem. Original problem was that we like to have a kind of underlying state that is visible only to our actions inside, to no one else. Okay, how can we implement the general with our bind and return? So currently, our actions don't take any additional values. So what we can actually do, we can pass an additional values to our action. So, for example, the state. Okay. So now, any action can perform any operation, can change the state, and return our value and the new state as a vector. Okay. So in our return function, we don't do anything, we just return, so the state is the same. What can we do to, what do we have to do to actually to bind, to execute our next action with the state? So first, we execute our action. No, so, okay, every action now is a function that takes a state. So we have to pass first the state. Then we execute our function. In this case, every function has an additional parameter that it gets the state, and return the value, my new value, and my new state. Okay? As a new state, exactly. Because the functions that I execute could potentially change the state, write something into it, and so on. Okay, so now when I have it, my value and my state, so I can pass it into my function. First, I execute my function with my value. Okay, the function needs to return another action, so I can execute this function, the new actions that I return with a new value. Okay, that's all. Now I have state provided by every action that I use in my framework. So at this point, when I execute now here my computation action, I need to provide an initial state. So the state could be just 0. Okay? Okay, so what we just did, we did not change anything on our computation, the layer that we actually work with, but what we change, just our basic functions, return and bind the internal implementation, and what we got for this, additional functionality that is hidden under our calculation. Okay? So far? Okay, good. Hopefully it doesn't crash us now. Okay, so now we have the state. How can we actually use the state? So how can we write something into the state and get it back? So every action that we perform now has to take a state as an input and return our array. So we can add, okay. So we can add additional function. Let's replace it with add to or set to state. That actually writes the value of the computation at this point into the state. How can we do it? So first, set to state. This takes the action. First thing we need to do always, execute the action and get the value and perform the write. So the function needs to return another action. In our case, an action that has a state as a parameter. So function, which takes the state, and what we return is our value, and write the value into our new state. So the new state is going to be the value. Okay? So when I execute this, I have now the value of 5, 5, 10 in my state. So what I do here two different operations. So one operation is I'm performing the action on my, where's my function? Here, I'm performing the action on my calculations. Another one, I'm using the state. I'm writing something to the state. So we can actually generalize it to a general set state function. Set value. We pass the value, and the result is an action that takes a state and returns value. Okay, so we can replace it just with function and the value I just got. Okay, this is my two functions. Now what I need another function that actually gives me the value back from the state. So I can implement it here, add from state. So at this point I like to add the value that is stored in the state into my computation at this point. So we can write it here. Def. Here we need a function action. Def and take the action. We perform our action, execute our action. Same scheme all the time. Okay. Add from state, yeah. Okay, here we get the value from the function. Okay, now we need the value from the state. So the return of it is a function that performs a state, and we return our value as value and state and our old state. Okay, when I execute it, I'm adding 10 into my computation. So same thing here, I'm performing two different things, executing the actions and setting the state, or reading from the state. We can actually decouple it. So this is my bind function. So generally here I don't execute an action. So this is my function that takes a state. And what I return, state as a first value and my old state as the last value. And I can replace it here. So, okay. So my action, this one actually, takes the state and returns the value of the state as a first argument and the state itself. So in my action, I can access it now when I execute my state action. Okay, I execute the action which returns my state, and now I have to return the combined computation. So I can do plus state and my value, and I have to return it. Okay, then 20, same result. Questions? Okay, so this is how we can operate with the state inside our functions without going into our layer that we actually work with our functions. Shall we do one more example with the state? For example, an increment function, okay? So I'd like to calculate or count how often I actually perform an increment function. Okay, so I need to get this value from my state and increment it and write it back. So we can generalize it. Let's move this here to my increment functions. Okay, a general increment function or count functions could be defined like this: def m count. So first I execute my action that gets the value from the state. Bind, this is get. Okay, I pass it to my function that I defined here. Then next step is I need to write it into my state, which is an action as well. So I return here set state, and I just increase my state. Okay, this is a general action I can use anywhere. We can add it into our function. So first I execute inc. Next step is I execute my function mCount, my action mCount, which returns a value, but I'm not interested in it. And I return just the value of my actions that I perform. Okay, so to make it here clear, let's remove set state. So when I execute it, no. Okay. Set value, okay. I should name it set state. Okay, here is it. Okay. Good. So,
When you're using the binding to store the state, if you have, in this case, you have sort of a linear progression where the state is just passed along or bound along as you go from one to the other. If you had a branching structure where you had added, if you had, your action had performed two adds in the same action, would that break this model, or how would that fit?
two adds in the same action.
So, yeah. If
you could do it. So when I use mCount, two actions that you execute after another. So the concept here is that the action is always executed in sequence. Something like branching, where you have two different values that you generate and write back into the state, you don't have it. Because the concept of it is sequence execution.
Okay, so you're saying that monads are always sequential, so you don't have
Correct.
to worry about that problem.
Correct. When you are looking for branching, in this case, you are looking maybe for arrows. Arrows support branching in your computations, yeah. As far as I know.
Okay.
Okay, so what we just did in general, we implemented already three different monads. So the monads are the combinations between the bind and return functions. They have to follow a certain rules. So what monads are in general, just a combination between the bind and the return functions. So you can see monad as a kind of abstract data types, same as a map or maybe a stack. A stack is defined by two functions, push and pop, that has certain signature. A monad is nothing else. The difference is that a stack is an abstraction above the data itself, how the data is structured, how do you access the data. The monad is an abstraction more above your functions. How do you structure your functions? How do you execute your functions? So the requirements under return and bind are, so return generate a monadic value, in our case an action for a value, and the bind takes my action, takes another function that performs the operation on the value of my action, and return the monadic value or monadic expression. So in our case, the actions, how we implemented it. Okay. So we implemented here three different monads. The first ones actually didn't do anything. It was the identity monad, a different derivation of it. So here we don't have the anonymous functions that we call. The difference is that we defined our monadic expression as a function, but you can see any value as a monadic expression and work with it. So the second one is a maybe monad that performs the nil check. So early termination, and you can use this, for example, for error handling. And the third one was the state monad, where we actually pass the state or manage the state under your code that you actually execute under the code you perform. So one problem when you use the bind and return directly is that you can imagine that you can have a really long list of actions that you execute in the chain, so one after another. So you have many bind, and return. It's a default pattern that when you rewrite it in a little bit different way, you see the pattern more clearly. You execute the action, pass it into the first value, execute the next action, pass it into the next value. So this is a pattern that you can really, really good abstract by a macro. And this is actually implemented in the Clojure contrib monad library by Konrad Heinze. And what is actually doing, you can write your actions same way as a let statement. So instead of the let statement, you write do monad. You execute your action, assign the value, and at the end you perform your operation on the action. So this actually, the do monad macro rewrites it into the expression above. So it's much cleaner, much more intuitive to work with. The code is really very concise in using it. The library is really powerful. The library provides almost all the, or most of the popular monads that are actually used in all other languages like Haskell or F# and others. So it has the identity, maybe sequence monads, state monads, writers that it use, for example, to do logging and so on. It provides a do macro, that makes it easy to implement the monadic actions or functions. And it has many functions that makes your life just easier. So what we did, we had to implement our inc, add, and other functions from scratch to actually support it in our actions. So you don't have to do it with the lift function. So what you can do, you can wrap your standard function, Clojure function, into the monadic function by calling the lift. So actually it lifts the default function into the monadic function, so you can immediately execute in your monadic actions. Okay, so it just converts the input value into the actions, in our case actions, and execute it in the monad. So additionally, it has many functions that work directly on the state. So the state case is a really, really common case where you actually write one particular value by a keyword, read the value from a keyword. You don't have to implement by yourself. It's provided automatically by the library. So before you start tomorrow, hacking your first monadic implementation, rewrite a web framework or request cycle. So 3 things needs to be considered. So these are the monadic laws. So the left identity, right identity, and the associativity. So probably this is relatively intuitive. When I wrap my value into a function and execute it, it has to be the same as a function. The other one is the same. When I have monadic expression and I execute it with bind and return it again, so I've wrapped it back into the function, I have to have the same result, and then the associativity. Okay, so short summary at the end. So monads, as you said already, are really suitable when you have execution of actions in chain. So actions as functions that are executed in chain, one by one. An advantage is that you can really provide additional functionality under the code that you're actually focusing on, like our testing framework or maybe the computation. So the underlying functionality could be, for example, the state. The implementation is actually that you can have different monads that implement different functionality, like error handling or writing a log, or maybe having the state. So instead of implementing, so when you have a computation, let's say a request cycle for a web application you write, you have usually the database as a state. You can, for example, the session you can use in another state. And you can have the writer that renders the page that you return. So you can actually write monad transformers. So it's like plugins that you can stick monads in each other, and then into the computation perform all the actions in one. You don't have to rewrite all the monads from scratch when you need a combined functionality. So the monad plus is extension to some of the monads. So currently, or in our example, our calculation return only one result or no results. So when you have computation or calculation that actually has multiple results, you can use this extension to the monads. And so when you're interested definitely in more, one of the best papers I read is Taking the Aqua Squad by Simon Peter Jones. It goes into the what is the purpose of monad. It's in Haskell, so about Haskell. So what is the purpose, where monads are used for STM, for I/O, and it's really good explained. Then on Clojure is series of blog posts written by Konrad Hinze, the author of the Clojure contrib monad library, and is really good as good point to start with. Okay, that's all. Thank you. Any questions?
Just when you're using for the state monad, you're doing binding. If you have very deep binding, are there any performance implications of that? That's, I guess, more of a general Clojure question.
Yes, so I actually didn't perform any tests in Clojure with it, so I cannot tell you how the performance is. So the other option is, of course, usually using the special variable, maybe references. So one thing that definitely, since you have many, when you execute many functions, when you chain many functions in each other, and maybe perform some looping, you have to be aware of when do you do recursion, when can you do tail recursion optimization, so actually explicitly use recur or not. You can run easily into the case where you actually have recursion that can actually fill up the stack.
Okay.
Okay. Thank you.